Example 4. A system of point charges. We have charge 1 coulomb at the origin 0, 0 and minus 2 coulomb at 0, 1 and 4 coulomb at 1, 0. The system like this. This is X and this is Y. We have charge here at the origin 1 coulomb. We have another one here at 0, 1 minus 2 coulomb. We have another one here at 1, 0, 4 coulomb. Find energy stored in this system. We need to find the potential at each point. Okay, so we have 3 points. Let's call charge 1 coulomb Q1. At 0, 0 is point P1. Charge minus 2 coulomb we call Q2. At point 0, 1 we call P2. And the charge 4 coulomb we call Q3. At point 1, 0 we call point P3. Q1 at P1, Q2 at P2, Q3 at P3. So we can draw as this. Then we need to find potential at point P1, P2 and P3. Potential at P1 we call V1. V1 is V12, means the potential that produced by Q2 at point 1 plus V13 is the potential that produced by Q3 at point 1. V12 is Q2 divided by 4 pi epsilon 0. R12 is the distance between point 1 and point 2. Okay, so we go back to see the figure. So the distance is equal to 1. Okay. So V12, we put Q2 minus 2. Okay, and R12, it's 1. So we have minus 2, 4 pi epsilon 0, 1. V13 is Q3 divided by 4 pi epsilon 0. And the distance between point 1 and point 3 we call R13, which is 1. So we have V13 equal to Q3 is 4, right? So 4 divided by 4 pi epsilon 0 and the distance is 1. Then V1 can be written as shown here. Potential at point P2, V2 is V21 plus V23. V21 is the potential produced by Q1. So we have Q1 divided by 4 pi epsilon 0 and the distance between point 1 and point 2. So R21, which is equal to 1. And V23 is the potential produced by Q3 at point P2. So we have Q3 divided by 4 pi epsilon 0 and the distance R23. Here we can see that the distance from 2 to 3 is the distance from 3 to 2 and it's equal to square root of 2. So we get this equation for V23. So we have V21 and V23 like this. Okay, so we add them together. Okay, so we will get this as the result. Potential at point P3. V3 is V31 plus V32. Okay, V31 is the potential produced by Q1. Okay, so we have Q1 divided by 4 pi epsilon 0 R31. So we have Q1 is 1 coulomb, right? So we have this equation. V32 is the potential produced by Q2, right? So we have Q2 divided by 4 pi epsilon 0 and R32. Okay, so Q2 is minus 2 coulomb. Okay, so we have minus 2 divided by 4 pi epsilon 0. The distance is square root of 2. Okay, so we add them up together, so we will get the V3. Okay, so V3 is going to be equal to this equation. Okay, now we have V1 and we have V2 and we have V3. Q1 equal to 1 coulomb, Q2 is minus 2 coulomb, Q3 is 4 coulomb. This is the equation for energy. So we have V1 Q1, V2 Q2, V3 Q3. So we will get this result. Rewrite the answer here again. We have the energy that we move 3 charges Q1, Q2, Q3 from infinity to the locations, and so we need to apply this work. Okay, so this work is transferred to potential energy inside this system. The energy does not include the energy stored in each point charge because each point charge has infinite energy.